So already we discussed in our previous lecture some fact about the motion in a straight line, and in today's lecture we will proceed with the same topic, motion in a straight line, and we will discuss some new things in detail. Okay, so the topic is motion in a straight line, and you can see that when any object, it's a small object or big object, whether it is a point size object or a big body, when they moves along a straight line, then the motion is said to be a straight line motion. It is also called a rectilinear motion, rectilinear. So recti means straight, linear means line. Recti means straight, linear means lines. So when the motion is on a straight line, then it is called rectilinear motion. It is also called 1D motion, one-dimensional motion, one-dimensional motion. So let me just highlight you the one-dimension motion. So what is the meaning of one dimension? So one dimension motion. So dimension means to discuss the dimension, let me take the a coordinate system having x, y, and z axis, and this is my origin. So one dimension means at one time, in one time, I will consider only one axis, that is called one dimension. Suppose the object starts from the origin and moves along the positive x-axis, this positive x-axis. So means that is the motion along x-axis. So this is the motion along the x-axis at one time. There is nothing happening along the y-axis. There is nothing happening along the z-axis. So it's purely the motion is along the x-axis. So it is called 1D motion. 1D motion. 1D motion means one dimensional. One dimensional means it is along a particular axis. But if I take the object start from O and moves along y-axis, so again it is a 1D motion, but it is along the y-axis. It is along the y-axis. At that time, when object is moving along the y-axis, at that time, the object is not moving along x and z axis. So it is again a 1D motion. 1D motion. So similarly, we can take along the z axis. We can take along the z axis. If the object starts from O and moves along z axis, then again it is the example of 1D motion. So what I mean to say, in 1D motion, at one time, there is only one axial motion, either along the x-axis or along the y-axis or along the z-axis. So if it move along the x-axis, so that is a straight line. So that's why it is called a straight line motion or a rectilinear motion. Axis is a straight line. Similarly, if it move along a y-axis again it's a straight line. So it is called a motion along the y-axis, a rectilinear motion or straight line motion along the y-axis. Similarly, if we take z-axis is also a straight line. So the motion is called a rectilinear motion along the z-axis or straight line motion or 1D motion along the z-axis. So this is the motion along the straight line or motion in one dimension. Dimension can be any axis or x-axis, y-axis or z-axis. You can take any axis. So this is a one dimension motion. Now let us go for some new things. So before going to the 1D motions, we have some basic terms. So the first basic term is what is a particle? So a particle is an object which has negligible dimension. And what is a rigid body? What is a rigid body? A rigid body is a combination of particles. When large number of particles they combine together, they make a rigid body. So it is a combination of particles, and when an external force is applied, there will be no change in its dimension. So rigid body is a very interesting interesting topic. So, so let us take some example. Let us take some example of a rigid body. Example of a rigid body. Okay. So let me take uh, a wire. A wire. This is a wire, and you know that it is made up of atoms, and it is made up of atoms. So let me divide into small segments. So these small, consider these small segment as atoms. So if I take the distance between the two atoms, suppose this is the first atom, and this is the second atom, and then third, and then fourth, and then fifth. Okay, so let me take the distance between any two atoms. If it is, suppose it is x micrometer, let me take it is x micrometer, or 1 micrometer is equal to 10 to power minus 6 meter. So if the distance between the two atoms is x into 10 raised to the power minus 6 micrometer, and if I change the position of the this wire, I just uplift this end of the wire, uplift, keeping this end as fixed, this end as fixed, and I just try to uplift this end, So now the position of the rod, that will be, this is the initial position of the rod, and now the actual position of the rod is this. Actual position of the rod is this. So if the distance between any two particles or any two atoms, that does not change, that remains x into 10 raised to the power minus 6 meter, even after changing the position of the rod, means rod is uplifted to the height h centimeter or meter above the original position. So the distance between any two particles, that is not changing. So it means this is a rigid body. This is a rigid body. Okay. One more example. You take the example of a fan. You take the example of a fan, and the blade of the fan, the blade of the fan, so even after the rotation, the distance between any two particles after the rotation, check the distance between any two particles, okay, make the two mark 1 and 2 on the blade, and so before rotation, note the distance between point 1 and 2. Suppose it is 2 centimeter. It is 2 centimeter. And now switch on. And when switch is on, then by some method, again try to find out the distance between these two mark by the pen or by the pencil. So again, if that is not changing, that is same after rotation, if again the distance is 2 centimeter, then it means the blade of the fan or the whole of the fan, it is a rigid body. You take any so let me take one example of a body which is not rigid, you know, so which is not rigid. So I take a body, suppose I take a plastic sheet, and so I note the distance between these 2 points, and it is suppose 2 millimeter. And if I uplift, fix this end, and uplift this end, and uplift the end in this way. So if the distance between the 2 points, that changes, because it will show bending, some bending. It's a plastic object, it will show some bending. So the distance between the 2 points, that changes, that is less than 2 mm. So it means this is not a rigid body, So what is the difference between a rigid body and a non-rigid body? In the rigid body, if we make any change in the position of the body, then the distance between its constituent particle is not changing, then it is said to be a rigid body. But if after changing the position of the body, the distance between the constituent particles that changes, then it is a non-rigid body. So this is all about the rigid and non-rigid body. So let us take some more points. So now, are you a particle or a rigid body? Now we talk about we human beings. So these two boys, they are discussing, are you a particle or a body? So this boy is asking this girl, are you a particle or a body? Likewise, this girl is asking this boy, are you a particle or a rigid body? So what will be the answer? So let us go for how to define a particle and how to define a rigid body. So as relative distance is less, you are considered to be a body, because the size of the boy and the girl, the size of the boy and the girl, that is comparable to the distance between the boy and girl. So when the size of the object, size of the two objects, that is comparable to the separation between the two objects, that is comparable to the separation between, suppose the boy is of 5 feet, girl is also 5 feet, and the gap between them, the distance between them, that is nearly about 5 feet, then the boys and girls, they will treat them like a body. Okay, so this is the body of the boy, this is the body of the girl, because the separation between them, that is also nearly 5 feet or 10 feet, approximately 5 feet or 10 feet. So in that case, we will consider them as a body. But if the separation between these two students, these two childs, that is much greater than their size. So size of the boy and girl, it is of 5 feet, but the separation between them is 100 kilometer, 1000 kilometer. So in that case, they will treat each other like a particle, So particle or a rigid body, they are relative term. They depends upon the distance of the object from the observer. I take one more example. Suppose one aeroplane is approaching the earth. So one child is on the earth. So the child appears to be a point from the people sitting in the plane. So because the relative distance of the plane from the child is large, so that's why the child, that will appear like a point. So as the relative distance is large, person appear like a particle, that will appear like a point. So the whole matter is of the relative distance. If the relative distance is small, then we can treat them like a body. But if the relative distance is large or very large, then whatever is the size of the body will appear like a particle. Even if you see the earth from the plane, that will appear like a particle. So that is particle and rigid body, they are relative terms. If the distance is small, between the object and the observer, then the observer can treat the object like a body. But if the distance between the object and the observer, that is large, then in that case, observer will treat the body like a particle. So if body is particle or body is a body, that depends on the relative distance. Now, rest and motion. So what is rest in physics? Rest means if the body is not changing its position, if the body is not changing its position with respect to the surrounding, then the body is said to be in rest. So you see the TV at rest, the fan at rest, this boy at rest. So they are not changing their position with respect to their surrounding. But if the fan move from here and it take the position over here, then it means the fan is in motion. So with respect to the surrounding, the fan is changing its position. So if I ask you one question, if I switch on the fan, then what term we will use for the fan? Is it in rest or is it is in motion? So it is in rest because it is not changing its position. Even the blades, they are in motion. The blades, they are changing their position with respect to the surrounding, with respect to the surrounding. So fan as a whole, it is in rest, but the blades of the fan, they are in motion. So now the blade of the fan are in motion, but fan as a whole, it is in rest. Car is moving or anything is moving, so that is the example of motion. We change the position with respect to surrounding, with respect to the time. That is called motion. Are the passengers in the bus at rest or in motion? So passenger, they are sitting in the bus. Are they in rest or motion? Bus itself is moving. So with respect to each other, all the passenger, they are in rest. Even with respect to the bus, they are in rest. But the passenger, with respect to the person, they are standing outside on the road. So the passenger, they are in motion. The passenger, they are in motion. So passenger in the bus are at rest relative to each other, but passenger in the bus are in motion relative to the people at bus stop. So see this animation, they are in motion with respect to even for these peoples who are moving in the bus, these passengers, they are in motion. These passengers, they are in motion. So motion is a relative term. For these people, for the people sitting in the bus, the passengers standing at the bus stop, they are in motion. But for the passengers stopping at the bus stop, for them, the passenger in the bus, they are in motion. So motion is a relative term. Now, what is rest? So a body is said to be at rest when there is no change of position with respect to time. And what is motion? Motion is the change of position with respect to time. So in this chapter, this is the kinematics, and we are studying motion in a straight line. So a body changes its motion. So a body changes its position. Body is in motion. Body is changing its position with respect to time. So it means definitely a force is acting on the body, a force is working on the body. But in kinematic, we are not concerned with the type of force, the nature of the force, or what is the cause of force which causes the motion. Only we are concerned with the motion. So actually, this is the application of the force. Application of the force is the motion. So in this chapter, basically, we are studying the application of the force. We are not studying the history of the force. We are not studying the cause of the force. We are not studying the nature of the force. So it is the kinematics. It is the study of the motion of the object. It is the application of the force. It is the study of the application of the force. Now, one more new term, which is a very powerful and important term. It is called the frame of reference. So let me discuss the frame of reference in detail. So let me go to the Zoom board. So what is frame of reference? Frame of reference. So before going to the frame of reference, let me discuss some important terms about our universe. So our universe is Our universe, it is made up of matter. It is made up of matter. And matter is classified as solid, liquids, and gases. So in the universe, which is made up of matter, all these things, everything, all the solid present in the universe, liquid and gases, they are in motion. They are in motion. So motion may be large or small. Motion is large or small, means might be possible that objects are traveling a distance in thousands of kilometers in a second, and might be possible that some matter, some objects, they are traveling only a few micrometer of distance in a second. So whether the distance is small or whether the distance is large, so we take the example of an atom, and in the atom you see that electrons, they are in motion. They are in motion. Even the nucleus is also shows a spin of the nucleus. So that is also in motion. So this is these are the smallest particle of the universe, which is called the atom. So even the subatomic particle, the constituent of the atom, they are in motion. So if the smallest entity of the universe is in motion and everything is made up of these small entities, so we will say that our universe is a dynamical universe. It is a dynamical universe. Dynamical universe. So, or we can say our universe is a dynamical system. It's a dynamical system. Dynamical system. So let me take with the help of a rough diagram. So this is our universe. This is our universe, which is a dynamical system. Dynamical system means the whole universe is moving. This full universe is moving. Okay. So might be possible that if I make the coordinate system x, y, and z, x, y, and z. So x, you can take any side as x, any as y, any as z. And one more coordinate system I take, it is the time. It is the time. So here I have 4 coordinates, x, y, z, and time. So with the help of these coordinates, x, y, z, and t, I can locate any star or any planet. I can study the coordinate of any star. Suppose this is a star. This is a star, and I want to find its position in the universe. So definitely I have to fix a coordinate system. I have to fix a coordinate system, and the coordinate system is x, y, z, and t. There are 4 coordinates. So with the help of these 4 coordinates, I can fix the position of any star or any planet in the universe, because you see the star is also in motion. So might be possible that after some time it changes its position. It goes to the new position. Right now it is at P. So after some time it reaches to a new position, which is Q. Okay. So here I take the initial time t is equal to 0, and after some time t is equal to t dash, it reaches to the new position. So what are the coordinates of this point P, and what are the coordinate of this point Q? So basically for this star, this XYZ, this is called the frame of reference. So this is called frame of reference. This is called frame of reference. So frame of reference is nothing but it's a tool to locate. It's a tool to locate anything, any object in the dynamical universe, in the dynamical system. So in the dynamical universe, when everything is moving, so it is necessary to fix something. And this is a purely imaginary system, X, Y, Z coordinate system, or this frame of reference. It's not a material system. It is not made up of any wires. It is not made up of steel. These are imaginary lines. These are imaginary lines. Imaginary lines. So with the help of these imaginary lines, we can locate, we can fix any object in the universe. So that is called the frame of reference. Now I think it is clear what is the meaning of frame of reference. So frame of reference, it is a set of coordinates. So it is a set of coordinate that can be used to determine position and velocity of object. So let me write the definition. Let me write the definition. Definition of the frame of reference. So it is a set of coordinates. Set of coordinates. And coordinate, what are the coordinate? X, Y, Z, comma, T. So these are the four coordinates. It is a set of coordinates that can be used to determine position and velocity of object. Position and velocity. Position and velocity of any object in the dynamical universe. Velocity of any object in the dynamical universe. So basically these are set of coordinates. And what are the set of coordinates? X, Y, Z, and T. So these X, Y, Z, these are called space coordinates. These are called space coordinates. And the last one, which is time, this time T, it is called the time coordinate. It is called the time coordinate. These space coordinates, they are also called the position coordinates. They are also called the position coordinates because with the help of these coordinates, we can find the position of any object in the dynamical universe. And with the help of this time, again, this time will help us to find the time of observation. Okay, so we will find the position and we will find the time. So at what time, what event is happening in the universe, what is the position of that event? Suppose any star from its position that try to move to another position. So that is called the event. Measurement of that change in the position, that is called the measurement of that event. So how the position coordinates are changing and what time it will take to change the coordinate. So we need four coordinates. Three are the space coordinate and fourth is the time coordinate. So this is about the frame of reference. Now the second part is called type of frame of reference. Types of frame of reference. So we have two types of frame of reference. The first is called the inertial frame of reference and the second is called the non-inertial frame of reference. So inertial frame of reference, they are those frame of reference which follows Newton's law, Newton's first law, that is called inertial frame of reference. So if any frame of reference that follows Newton's first law, So that is called the inertial frame. But if any frame of reference that does not follow the Newton law, it means it is called non-inertial frame of reference. So let me discuss the inertial frame of reference and non-inertial frame of reference one by one. So here I take inertial frame of reference. Inertial frame of reference. And here I take non-inertial frame of reference. So the first point, any frame of reference, and the frame of reference basically it is a coordinate system x, y, z, and one coordinate is time t. So suppose I have any point P, any object at this point P having the coordinate x, y, z, and t. So these three are called the space coordinates. These are called the space coordinate. And fourth is called the time coordinate. The fourth is called time coordinate. So we have this set of coordinate. So if this coordinate system follows Newton's first law, it follows Newton's first law. Follows Newton's first law. Newton's first law. Newton's first law means Newton's first law tells us that we can find a reference frame relative to which a body remains at rest or in uniform motion along a straight line when no net external force act upon it. So suppose this coordinate system, it is moving along x-axis. It is moving along x-axis. So it will keep on moving. It will keep on moving along the x-axis. It will keep on moving along the x-axis means it will keep on moving along a straight line. Along a straight line in the absence of an external force means F external is 0. There is no external force acting on this frame. External force, बाहर से कोई force इसके ऊपर नहीं लगती. बाहर से इसके ऊपर कोई force नहीं है. F external is 0. But still it is moving in a straight line. It is moving in a straight line. It is moving in a uniform motion. So it is moving in a uniform motion. It is moving in a straight line. It is moving in a uniform motion. So moving in uniform motion along a straight line. Along a straight line. Along a straight line. Then it means this frame of reference x, y, z. In that case, this x, y, z frame of reference, it is called inertial frame of reference. It is called inertial frame of reference. So the motion is uniform motion. And one more thing is that the important point which is to be noted here. So in this case, when it is moving in a straight line, so it should be non-rotating. Non-rotating. It should not rotate. It should not rotate. So non-rotating. Non-rotating. Non-rotating, and second is unaccelerated. There should not any acceleration. Unaccelerated. Unaccelerated. So if the frame is not rotating, means rotate. If it rotate, means it change its coordinates. Means x become here, y become here, z become here. So it means it is rotating in anti-clockwise direction. Or if it rotate in clockwise direction, this become x, this become y, this become z. So if any type of clockwise or anti-clockwise rotation is there in the frame of reference, it means that is not inertial frame. Okay, so it should not rotate. It is non-rotating. And second thing is that should not be accelerated because there is no force, because F external is zero. F external is zero. So we know that when F external is zero and F is equal to M into A, F is equal to M into A. When force is zero, so the acceleration is zero. So acceleration is zero. Acceleration is zero. So it is unaccelerated. Unaccelerated means acceleration is equal to zero. So two important things are there. First is the inertial frame, they are non-rotating. And second thing is that they are unaccelerated. Unaccelerated means acceleration is equal to zero. Acceleration is equal to zero. Now we go to the non-inertial frame. So non-inertial frame, suppose I take this as the x, y, z. This is my frame of reference. So if it is rotating, rotating means now the coordinates that changes. This becomes x, this becomes y, this becomes z. So it means x shifted from here to here, and y shifted from here to here, and z shifted from here to here. So it means our frame of reference is moving in anti-clockwise direction. It is rotating. It is rotating anti-clockwise. Anti-clockwise rotation is there. Okay. So if rotation is there, so it is called non-inertial frame. And second thing is called if it is accelerating. If there is acceleration. So if there is acceleration means there is a force. There is a force. Net force is there. Net acceleration is there. So if acceleration is there, the frame is accelerated, the force is there. Okay, so that frame is called the non-inertial frame. So what are the examples of inertial and non-inertial frame? So let me take one example of the inertial frame. So our earth, you take the example, our earth it is an inertial frame. And if any plane take off from the earth, this is earth, and any plane that take off from the earth, this is a plane, and take off from the earth is inertial. Earth is inertial, but if plane take off or land, so that is a non-inertial frame. It is non-inertial. No, because it is accelerating, it is increasing its speed. So non-inertial. So plane taking off or landing on the earth is non-inertial, but earth is inertial. So we will discuss some more concept, some more good things about the inertial and non-inertial frame in our next lecture. So that's all for today. Okay, Astha. Okay, Ayush.
Thank you, sir.
Okay, bye.
Bye, sir.
Bye.